All right, we're going to start with a discussion of Boyle's law. Boyle's law relates pressure and volume. And it's pretty straightforward, as you can see in the image. If you take a gas and you put it in a smaller space, the pressure is going to increase, right? So if the volume decreases, the pressure increases because there's going to be more collisions in the smaller space. So the formula that we're going to need for Boyle's law is up in the right-hand corner here. Pressure times volume before equals pressure times volume after. So let's go ahead and look at this math problem. The pressure on 400 milliliters of gas is raised from 20.5 kilopascals to 80.5 kilopascals. What is the final volume of the gas? So our formula is up in the right-hand corner there. Pressure before equals pressure times volume before equals pressure times volume afterward. All we're going to do here, and you'll have to excuse my writing, I'm going to do the best I can here. I'm just going to plug in the numbers. So my pressure before is 20.5 kilopascals. And I am going to write the units in to keep myself organized. And I'm just going to write that in parentheses for times. The volume before is 400 milliliters. And then after, the pressure in the problem is being increased to 80.5, so my after pressure is going to be 80.5 kilopascals. And my after volume is my unknown. So that's pretty straightforward. We can just plug the numbers in using this formula, right? To solve this, to isolate volume 2, I would want to divide both sides by 80.5 kilopascals. And then it's a matter that's going to cancel out to figure out the volume of just doing the math. And just as I pause it, I went and did the math for this. Kilopascals is going to cancel out, so I'm going to be left with milliliters. And it ends up being 101.86. I'm just going to round that off to a nice even 102 milliliters. And my check with this is, I know with Boyle's law, if I increase the pressure on a gas, the volume should get less. And that's exactly what happened here. The pressure increased and the volume went from 400 down to 102. Next, we're going to move on to how to do Charles' law problems. So Charles' law relates the variables temperature and volume. So in this case, if I take gas, and this is a piston that can move up and down. Let me go ahead and draw on this. So if this piston can move up and down, if I increase the temperature of this gas by heating it and the gas is able to expand, it's going to expand and its volume is going to increase. So Charles' law simply states that as temperature increases, the volume of a gas increases. So math-wise, Charles' law is basically a proportion where we have the volume before, V1, divided by T1 equals volume 2, volume after, divided by temperature after. So the problem below is almost exactly like one of the ones you saw on the pre-quiz. So a 200 milliliter sample of neon gas is collected at 300 Kelvin, and you do have to have your units in Kelvin for temperature to be able to do these problems. Assume the pressure remains constant. What would the volume of neon be at 270 degrees Kelvin? So I'm going to go ahead and just plug in numbers here. So I'm going to start with V1. My volume before is 200 milliliters. And then my temperature before is 300 Kelvin. And it's asking me, assuming that the pressure remains constant, what would the volume be at 275 Kelvin? So I know my temperature after. I just need to know what my after volume is. So the best way to attack this problem is probably to cross multiply. So I'm going to go ahead and cross multiply V2 times 300 Kelvin. And I'm going to cross multiply my 200 and my 27 point, or should be 275, not 27 points. And again, that's not supposed to be a period there, so that's 200 times 275 is going to be equal to 55,000. And I'm going to write that as milliliters Kelvin times Kelvin. And then it's just a matter of dividing out. So I'm going to divide both sides by 300 Kelvin. That's going to cancel out my Kelvin. And then after I do my math, I'm going to see that volume number 2, so the volume after, is 183.3 repeating. So it's going to write that as 183 milliliters. So the next thing to ask myself is, does that make sense? So the gas got colder, the temperature went from 300 to 275, the volume should have got less, and it did. So that checks out. So bottom line, now you should be able to handle the math problems for this section. If you need to go back and watch this video again, go ahead. And there's also plenty of videos on YouTube on how to do Boyle's Law and Charles' Law problems.